In section 3, we cover the ideas of modeling with linear equations. Now, a lot of people might find this to be initially difficult, but if you're just a little systematic in your approach to these problems, you'll find that typically the mathematics is easy, so it's only a question of setting up the problem and then solving an easy mathematical equation. Now, I pulled this from the OpenStax text for our class, and it's a pretty good idea. Actually, I would recommend all of you to read through this section. It's really a pretty good section. But here's pretty much the procedure you can follow if you need a laid out procedure, although all problems aren't exactly the same and there might be some subtle differences. But one of the first things you want to do is identify known quantities. You want to assign a variable then to your unknown quantities. And that's usually what you're going to solve for, is the unknown quantity. And if there's more than one unknown quantity in these linear equations that we're going to set up, you can't solve the equation. So what you need to do is you need to find a way, and there always is, otherwise you can't solve the problem. There's always going to be a way to write the second unknown term in terms of the first term. And finally, write an equation that represents these ideas using the variable you set up, possibly a second equation that you had to come up with so you could write a second unknown in terms of the first equation. So you write out this equation, and it's probably going to be an easy algebraic equation for you to solve, and then you just solve for your value. So let's work through some problems. So I pulled this from the exercise section. For the following exercises, use a scenario. Two different telephone carriers offer the following plans that a person is considering. Company A has a monthly fee of $20 and charges 5 cents a minute. Company B has a monthly fee of $5 and charges 10 cents a minute for calls. So I'm going to start here with question 10. It was find a model of Company B's plan. So how will we proceed here? Well, Company B has a monthly fee of $5 and charges 10 cents per minute. So how do we set up an equation that represents the total cost? Well, our cost looks like it's going to equal a fee here that we pay every month plus some 10 cents per minute times the number of minutes. Well, this 10 cents a minute, cents per minute, that looks like a rise over a run. This looks like a slope. So really, if we're going to model this linearly, we have cost equals, so cost is y here, so cost equals mx plus b. So cost equals, well, m is our slope, and that's our number of cents per minute. So 0.1 is our slope, and actually this is not really cents per minute. Cents per minute would be 10 cents per minute. This is actually in terms of dollars, and this is important. So 0.1 is $0.1. 10 cents per minute is the same thing as $0.1 per minute. And why am I changing this to dollars, or concerned about this being dollars? Because my fee is in dollars. Now I could have switched this to cents and made it 500 cents. So this is also 500 cents. And then I could have used 10. And in fact, let's write the equation both ways maybe. So first, in terms of dollars, if I write this, so 0.1 times X minutes plus B is going to be our fee then of 5. So in terms of dollars, it would be 10x plus 50. And that's the answer to that question. Just simply that. Now if I average 200 minutes a month, then my costs are going to be equal to 10. I guess we'll use the cents one. 10 times 200 plus 500 equals 2,500 cents, and that equals $25. So this is one style of word problem we'll solve, where we have information in the problem, and then we have to decide how to set up the slope and the intercept in our linear equation. And then we can use it to solve for actual values. Another type of problem are these like puzzle problems, where you'll have different relationships of variables, and you'll have to then set up an equation. For example, Ben originally filled out 8 more applications than Henry. Each boy then filled out 3 additional applications, bringing the total to 28. How many applications did each boy fill out? Well, when solving these types of problems, you can refer to this table in this section to help you. You'll need to come up with operations that represent the statements in the problem. So when we look at this question, what are we trying to figure out here? So we want to figure out how many applications each boy filled out. Well, we know the total number of applications was 28. And so this equals the number that Ben filled out plus the number that Henry filled out. There's no E in this Henry. And typically there's no E in Henry anyways. So now we have to relate the number of applications that Ben and Henry filled out. And the first thing we can do is we can look at the information up here. We can see that Ben filled out 8 more applications than Henry. So one number exceeds another number by A. So that's going to be like X plus A. So let's say here that Ben filled out X plus 8. Let's leave some space here. And Henry would have filled out X. So if Henry filled out 10, Ben filled out 10 plus 8, 18. That would equal 28, if that were the case. But there's more information. So then it goes on to say that each boy filled out 3 additional applications. So Henry filled out 3 more, and then Ben filled out 3 more. And that's it. Now we've got ourselves an equation set up here. Reasonably simple to solve. We just need to solve for x. So let's go about doing this. Let's see. Let's simplify this stuff here. Equals x plus 11 plus x plus 3, which means we're going to have, let's combine terms over here, we're going to have 2x plus 14. Alright, now I want to get x on one side by itself, so let's subtract off 14. That'll give us 14 equals 2x. Let's then go ahead and divide both sides by 2, and we get x equals 7 as our answer. So that's what x should be. That's x here. And it's also the same x here. So then Ben filled out 7 plus 8 is 15 plus 3 is 18. And Henry did 7 plus 3, or 10. Just to check, we add these together, they equal 28, and that was what they should total. Another type of problem we'll solve are called geometry type problems. Might ask a question like, suppose I have a square whose length is 20 and perimeter is 45. Total perimeter is 45. Find the width. Given that we have an equation for the perimeter of a rectangle here, where perimeter equals 2 times the length of the rectangle plus 2 times the width. Well, here I'll pluck the information from the problem that I need for my variables. The perimeter obviously is 45 and the length is 20. For my width, I don't know, and that's what I'm going to calculate. So I'll set my relationship up. 45 equals 2 times 20 plus 2 times the width. And then I'll solve for w. I worked the algebra. I did quickly here. You can work that on your own. 45 minus 40 divided by 2 equals 5 over 2 equals 2.5. So the only thing left to do is check this. Make sure that it works in our equation. So our width is 2.5. So we have 45 equals 2 times 20 plus 2 times 2.5. So this equals 2 times 20 is 40. 2 times 2.5 is 5. This equals 45. So 45 does equal 45. So that looks like we did a good job.